And for this one, we're section 3.7, which again is not a big deal. Big thing is for this one, we're doing transformations of polynomial graphs. Okay, so two things on this one. We're going to review a little bit over some different things. And a lot of it's going to be similar to when we were graphing quadratics, because when we're graphing quadratics now, in that case, we were looking only at x squared. This one, you may have to graph some x squared, so we may do a quick review on that one. We may have to show you a couple of new ones that we haven't done yet, but they're really similar to what we've been doing when it comes off those. So before we get to the new ones, let's back up real quick and let's give you one like where you have to graph. Let's say we're doing like f of x equals x minus 2 squared plus 3. All right, hopefully everybody remembers what you got to do for this one when it comes off of it. That if it's x squared, hopefully you remember that if you're doing x squared, that's the parabola, the U-shaped graph. And then normally that would be at 0, 0, but because of the numbers here, that means we're going to have to move these things around. The 2 on the inside means we're going to move it to which way? Right. To the right, yeah, because it's always opposite horizontal, right? Because so if it's -2, normally that's this way, but you go opposite direction, so you're going to go to the right side. The number on the outside tells you how much to go up or down. In that case, we're going 3 up. All right, so instead of being at 0, 0, we're going to go 2 spaces to the right. We're going to go up. 1, 2, 3. That would put us right here. And then normally we would pick a point and kind of plug it in, but for what we're going to do now, we're just going to do a quick sketch of it. So we got a graph that would look something kind of like that. Okay, now this one, here's where it's kind of important. Make sure it's a U-shaped graph, because on the last test, which has been a while back, some people had a graph that looked kind of like that. That's going to be more absolute value. Some people gave me a graph that looked kind of like this, where it was, there's like a block U. It's like, well, no, not exactly that either. So just make sure it's more of a U-shaped graph when it comes off of it. All right, everybody remembering that now, hopefully? Hadn't been too long ago when we were graphing those. All right, so here's what we're going to do. We're going to add in a couple of new graphs on this one, but they're going to follow that same pattern. It's more of just knowing what they're going to be for this one. So the new graphs we're going to look at. We're going to do x to the third and then x to the fourth. All right, and we've already kind of been doing some x to the third, so hopefully everybody's okay with that one. The x to the third, it looks like x squared on the right side of the graph till we get here. And normally if we did x squared, it was going to turn and go back up, because if you squared a number, it was always going to be positive. X to the third, if you plug in a negative number, it's going to be negative. So this one's going to keep on turning, but now it's going to turn and go down like that. But the main thing is, again, it's still going to cross through at 0, 0. And if you do x to the fourth, this one, it's similar to x squared. The big difference on this one is that for this one, it comes in and it really bottoms out and does something kind of like that. This thing really doesn't start to turn up until you get to 1 or until you get to -1. Because if you do 1 to the fourth power, that's going to be 1. If you do -1 to the fourth power, that's also going to be 1. But because if you're doing the fourth numbers, if you multiply, let's say your number was like a half. If you do a half times a half times a half times a half, you take a half and you keep cutting it smaller. So those numbers keep getting smaller and smaller and smaller. So it's going to bottom out like a lot on that thing. So if you had a half in there, you did a half times a half, that's a fourth. The fourth times a half is an eighth. And the eighth times another half is the 16th. So now you're looking at like 0.06 instead of what we're doing. So it's going to be really small. And then all of a sudden, once it gets to 1, then it shoots up and goes off in a hurry. Okay, so x to the fourth and x squared are pretty similar, but again, the big difference is this one's more of a U shape. This one's more like it's more like a flat bottom. Almost looks like the hull of a boat, almost like some big yacht ocean liner. It kind of flattens out in the bottom a lot of times. Okay, so but now here's what we're gonna do. All we're gonna do is we're gonna take these one of these three graphs we've got, and we're just gonna transform them. We're gonna change them as it come off of it. So for this one, we may just ask you a couple questions before we do any graphs on this one. How do the um, I think this is the way they word some of the problems. How do the transformed graphs compare to the parent function? Okay, and when they're saying parent function in this case, they're going to talk about either x to the third or x to the fourth, or just could be that it's just even x squared. But it should reference back to one of those two. All right, so for number one, we're going to do 3x to the fourth and then minus 18. Okay, and remember when we're doing our up, down, left, right, when we're doing horizontal movements and our vertical movements, that's everything back behind it back here. So we don't have like this one doesn't have a parentheses, so there's no vertical, there's no right or left movement for this problem. The negative 18 in this case would be just that we're going to move it 18 spaces down. All right, and then the 3 in front, it's kind of like the slope. Again, not exactly slope, but kind of like slope. So if it's not an up, down, left, right movement for the number in front, because if you look in front of it, that's all. It's a different kind of number. Anybody remember what the number in front stands for? What we call it?
Scale factor.
All right, scale factor. So it's either going to be a think about remember the rubber band.
Stretch or
Yeah, we either took the rubber band and we either stretched it out 3 times as far, or we took it and compressed it for that thing. So in this case, if it's 3, you're stretching your hands out 3 times as far. So that would be a stretch of 3. Yeah, so they either say stretch or shrink, or sometimes they'll say compress if it's a fraction. So yeah, so bigger than 1, it's a stretch. If it's less than 1, it's either going to be compress or shrink. They'll kind of throw out either one of those two words there. Okay, so that's all they're going to ask you to do is that if you started off with x to the fourth, what do the numbers around it do? So the 3 would make it a stretch. The 18 on the end would make it go 18 down. And I don't know if I'd ask you to graph this one, but if I did, it'd probably be more of a multiple choice one. If you had to graph that one, we would take x to the fourth, and we're going to drop it 18 spaces down. So, 1, 2, 3, 4, 5, 6, 7, 8. So let's say that was 18 spaces down here. So it's going to be that kind of flat bottom thing. But a stretch of 3 would mean that instead of it being, so again, if we start off with x to the fourth, it will look kind of like that. Again, just doing this very lightly because that's kind of where we're starting with. Drop it down 18 spaces. So now we're looking at this. But then the stretch of 3 means now we got to stretch it out. So these sides of it should then go up a little bit quicker. So it's going to be more kind of like that. Okay, and without anything to reference to it, you can't really tell that this is stretched out because, you know, you just couldn't really tell it in that case. Okay, the only way you'd be able to really tell it was if it was a stretch of 3. If you had one like this, then you'd be able to see it. So it'd be more like that, if you did something like that. So you'd almost have to have x to the fourth there. So then this would be one where you could, again, so you could see where it's getting stretched out so it's taller. But without having a reference graph, then you never would really be able to see that. give you another one here real quick. Let's do f of x equals x plus 4 to the third minus 2. Okay, same thing. If they ask you just to talk about what it is, not do anything with it, the 4 on the inside means it's going to go 4, again, opposite direction, left, right. So normally plus 4 to the right. In this case, we're going to take it 4 to the left. The number on the outside tells you how much to go up or down. You do whatever it is. If it's negative, we're going down, so that's 2 down. So 4 left and then 2 down. Yeah, I don't know if I can get over there, so we'll go down here to the next page. All right, and again, normally I'm just going to kind of pencil this one in a little bit. If we're going to do x to the third, and you don't have to necessarily do this, I'm just putting it here so we can see it. There would be x to the third. That would be the parent function of x to the third. So then they're going to ask, if they ask you to graph it, this one that shouldn't be too bad. Now we're going to go 4 left. So 1, 2, 3, 4. And then we're going to go down 2. So normally where this would have crossed at 0, 0, now we're going to go 4 left and down 2 and put it here. So now we're going to do that exact same graph, but we're going to use it with this point. It's kind of like the transition point. So it should be one of those where it will look something like that, where we've just kind of taken this graph and scooted it over here. Okay, and then here's where we can kind of think about what we're doing too. Going back to that lesson 22 we were talking about yesterday, where we did the end behaviors and how it goes in this case. If you look back at this one, it's a positive. It's 3x to the fourth. It's a positive number and x to an even power, so both ends have to point up. This is a positive x to the third power, so the right side is up and the left side is down. So it's still kind of borrowing on that same thing there with those. All right, so for this one, let's go negative. Let's go x minus 1 squared minus 3. Oh, not third. Wait. X minus 1 to the third minus 3. Oh, bad. Okay, so again, x to the third is our parent function that we're looking at. But the 1 on the inside, again, opposite direction, so not 1 to the left, 1 to the right. 3 on the outside means we're going 3 down. And remember, the negative in front means you got to flip it upside down. So now normally with x to the third, the right side was up and the left side was down. But if you flip this thing upside down, that's a, let's see, what do we call it? It was a reflection in the x-axis, which means we're just going to flip the graph upside down. So now instead of the right side up and the left side down, it's going to be the opposite. Now the left side is going to be up and the right side is going to be down. So now it's like a negative slope line, because this is x to the third is similar to a positive slope line. If it's negative x to the third, that's similar to a negative slope line, so it should be something that's kind of like that. So now your left side is up and your right side is down. Okay, so graph-wise on that one. Again, normally x to the third, again, just so we got the visual of it, will look something like that. But again, we're going to move it 1 space to the right. We're going to go 3 spaces down. 1, 2, 3. So that'll put us here. And normally it would go through like this, but again, we got to reflect it. So now we're going to flip it. So now it's going to go the opposite. Now it's going to look something kind of like that. And again, just kind of leaving that lightly there, just to say that's if we started with x to the third, it would look like that. But again, we're going to move it one space to the right, three spaces down. Instead of going this way, the negative means we got to flip it. So now it's going to go this way. Okay, and then the last thing they'll do now, if they make you graph one more point, there's not really any quick, easy way on this one, but probably the easiest thing to do is whatever your x value is. So if you had to find one more point for this one, if this thing is at x equals positive 1, probably the easiest thing to do then would be to plug in x equals 2, plug it back into this equation, and just see what that next point would be. And I can't remember if it's multiple choice, it'd be pretty easy to pick. But if it's not multiple choice, if they actually make you plot some points, I think you've got to plug in one more point. So for this one, you'd have to plug 2 back into this equation and see what that next order pair would be. Because we've got this one. We know this would be at 1, -3 that's here. But to get the next point, just so we can do that, let's take the x equals 2 and plug it back in here. So it's going to be -2 minus 1 to the third minus 3. And that's going to be our y value there. So 2 minus 1 is 1. 1 cubed is still 1. But the negative is hanging out front there. Minus 3, so -1 minus 3 would be -4. Okay, so we plug in x equals 2, we get the ordered pair that's at 2, -4. So 2, -4 would be the next number down on our list. That would put it like right there. Okay, and again, so if they make you graph it, you've got to have where you're moving it to. So, and again, the easy part is we're starting at 0, 0. We're going to move it one space right, 3 spaces down. So that would put this point at 1, -3. And then if they don't give you the multiple choice and you have to plug it in, you just have to pick the next number to the right or the left of this number. So if that's at 1, you can either plug in 2 or you can plug in 0. It doesn't really matter which one. Just you got to find one of the pairs just by plugging in some number to kind of get you there. And it should automatically draw the graph for you at that point once you got it picked up. Okay, and then the last thing they'll talk about, and it's not a big, huge deal, but it is something that kind of helps with some of the graphs as you go back and do some of these graphs a little bit later on, is they're going to talk about whether a function is even or odd, or neither. Okay, and do you want the hard definition or the easy definition? Okay, somebody said they want the hard, so you can see me after class. I'll give you the hard definition. The easy definition, if it's an even function, I always ask because somebody always likes the hard part. So, we'll get a one-on-one session for that one later on. Even functions, all exponents are, weirdly enough, even.
Is that 4 or 3?
Do what?
Is that 4?
I mean 4.
Are we still on 3?
No, we're still on 3. Yeah, so if it's even, odd, or even functions, if it's an even function, all, and that's the keyword here, all the exponents are even. So guess what odd functions have? All exponents are odd. All right, and if it's neither, well, it's got a mix of odd and even exponents. Okay, now again, technically that's not the mathematical technical definition, but if you just want to look at something and go, oh, I can just look at it and tell if it's even, odd, or neither, that's all you have to do. You just have to look at it. Now, if it is an even function, that if you have even functions, they have y-axis symmetry. Which means if you move, basically, and think about that one, that's like x squared. If you think about x squared, when we're doing the graphs on that one, that anytime you do the graph of x squared, if we went back to just the basic graph of it here, that everything is spread out equally from the y-axis. So, if we were graphing this thing, if we went 1 point here to the right, we knew that if we went over 1 and up 2 for this thing, we'd go over 1 and up 2 for this thing. That it's always equally spread out along the y-axis. That if you spin this thing around the y-axis, it looks exactly the same. And that's going to be the true thing for x squared or x to the fourth or for any of those. That's always going to have that y-axis symmetry. If it's odd functions, that's one that's a little bit harder to see. But odd functions have symmetry. This was not quite as easy. With respect to the origin. But that's your x to the third, your x to the fifth, even slope in that case would be, if you think about slope, if you go back to x, just y equals mx plus b, that if you're doing x to the third, the respect to the symmetry part is basically that if you're doing, sorry, I'll bring it back here a second. If you're doing x to the third, if you're going, over 1, up 1, well, to get it respect to symmetry, do everything backwards. You go left 1 and then down 1, which will get you this point that would be here. So everything is backwards with respect to the origin. That whatever you do to get here and here, to get the symmetry part, you do the opposite. You're going to go this way and then that way. So everything is backwards, kind of mirror image from the point when you're talking about the origin in that case. Okay. Now, again, the easy part of it is they're going to ask you, is this thing even? If it's odd, or is it neither? And in that case, they're probably wanting making an equation. They'll just give you like some numbers, just give you some terms. So, okay, it's 3x to the fourth minus 18x squared. Because it really doesn't matter if it equals 0 or if it doesn't matter. It's just the expression and the terms that you're looking at. Okay, so what we got? How many, what are the powers? 4 and 2, both even, right? So they ask you, is it even, odd, or either? It's even. If we go 6x to the fifth minus 2x to the third plus x. All right, we got x to the fifth, x to the third, and just x. All right, so what power would be on the x then? Technically, it's x to the first, right? So if you look at your powers, 1, 3, 5, they're all odd. All right. Here's where it gets a little. Here's about the sneakiest thing they can do. I say it's 4x to the third plus 15. We got x to the third, and we've got nothing, right? So what do we do with the constant? All right, it's nothing, right? In that case, so what is nothing? But if you gave nothing a number, what would it be? 0, right? So technically, a constant here is x to the nothing power. So in that case, that's x to the third, that's x to the nothing power. If that's 3 and that's 0, that's odd, that's even. Yeah, that's one where that would be a neither. That's about the sneakiest way they can get on that one. If they give you a constant, constants will throw you off a little bit because most people go, oh, it's just a constant, I don't have to worry about it. Yeah, you still have to kind of do. You still got to realize that if it's a constant, it's technically x to the nothing power because there's nothing there for the x. So you still got to kind of think about it that way. All right, and then obviously, if you had 4x squared minus 5x plus 3, That's x to the second, that's x to the first, that's x to nothing. You got a mix of evens and odds, so that one also would still be a negative there. Okay, now which means, one more real quick, that if we had 8, negative 8x to the 6 plus 2, all right, that's x to the 6th power. Again, if it's 2, technically that's 2 to the x to the 0 power. So that's x to the 6th, x to the 0. Both of those are even, so that would be one where that would actually be, something that's even there. Okay. All right, and that's that last little piece. So the back, so section 7, again, it's more of just a couple of new graphs. We've talked about x to the 3rd, but we haven't really talked about the movements and how it goes. So that's the part of it. X to the 4th is a new graph we've got, and then the whole concept of even, odd, and neither. And again, there's a much harder way that they talk about it and explain it, but just to look at it, it's really easy. You look at the powers of x, and whatever your powers are, you just figure out if they're all odd or even or neither or whatever it's going to be, and then just kind of go from there. Okay, again, if it's even, you've got y-axis symmetry, which means the sides of it will look the same, as you're going up or down the y-axis. If it's odd, you're moving like x to the 3rd, that everything is kind of backwards. If you go over 2 and up 5, well, over here you'd have to go over to the left and then down 5 to kind of get that for y-axis symmetry.